Today, we will continue composite functions and looking at Introduction to Composite Functions, which is lesson 4.3. So the main goal of today's lesson is at the end of the lesson, you will be able to determine the value of a composite function at a point, equation of a composite function. I'll explain what all these mean at the end as we go through this lesson. So the key concept is that the value of a composite function can be determined at a point, and also we can determine the equation of a composite function. So what are composite functions? So composition of function is when we're given f and g. Given f and g are two functions of x, the composition of f and g is f g at x, or is written as f of g at x. So it's read as stated here, f of g at x. So f of g at x, or f of g at x. Now, we can illustrate the definition by looking at a little diagram here. So if you look at such as f and g, we have function f and g, we have function f here and function g. Think of the x here, and this is your y value, and the x and the y value. So here we have two functions. To determine g, f of g at -1, we always start on the inside. So we start at g of -1, then the value for g of -1, we make it f of that value. So let's look at g of -1. So here we have the function g of x. So -1, the value of g of x, when x is -1, g of x is 2. So now g of -1 is 2. So we got there. Then we take our value given here into f of 2 now. F of g of -1, so -1 here, it's 2. So now we can replace this g of -1 with 2. Then we go to the next diagram and follow the arrow. Now f of 2, which is here, f of x of 2, when x is 2, f of x, and the value is 3. So we can say, conclude that f of g at -1 is 3. So we'll go on to a recap of how we calculate the little function. Let's get started here. Here are two function machines. The output of machine A is the output of machine B. So here we have what is the output for machine B for each point in machine A. So think of input-output. So let's start with the first one. We have x equals 3. So if x equals 3 here, we substitute the value 3 into the first machine, which is 2x plus 3. So we can 2 times 3 plus 2 times 3 plus 3. So we'll have it look like here. So substitute x equal 3 into 2x plus 3. So that'll give me 2 times 3 plus 3 equals 9. Next, we substitute x equals 9 into machine B. So this will give me 1 over x plus 5. So 1 over 9 plus 5. So it is 1 over 14. Now this is the output for machine B. Let's look at another example. So we'll follow through. So substitute x equals 0 into 2x plus 3. So we have 2 times 0 plus 3, which gives me 3. So next step, substitute x equals 3 into 1 over x plus 5, which is 1 over 3 plus 5. Gives me 1 over 8. So this is output machine B. So here we have input output. Now this will be the similar analogy we'll be looking at when we're looking at composite function. Let's look at the first example. Example 1. In this example, we have 2 tables, and we're going to define 2 functions. So we're asked to find f of g at -1. So first determine f of g of -1. First, find so g of -1. So we go to our chart here. G of -1. We discovered it's actually g of -1 is 2. So here is our g of x. Here. So we can use g of -1 is 2. So g of -1 is equal to 2. So follow through from the function table. Now we're going to find f. Now since g of -1 is 2, we can say that f of 2. We go to this chart here. When f of 2, when x is 2, f of x is equal to 0. So we can put everything together, and we can say f of g at -1 is equal to 0. Let's look at the second example. Here we have f of f at 1. So first, find, and always start from the inside, f of 1. So f of 1 is equal to, now here we have f of x here. So when x is 1, f of x is -1. So now we have f of 1. So f of 1 here, we can say it's -1. So replace it. Then f of -1 back here, negative 1 is equal to 3. So we can conclude f of f at 1 is equal to 3. If you wouldn't mind, you can pause the video, and on page 294 of your textbook, you can try question 1 on page 294. So that's for you as a practice question. Okay, let's look at the next example. Example 2. Here we're given a graph. Actually, we're given two functions, or two graphs, and we're asked to find the value of the composite function. So in this case, we're not given a chart as in the previous example. We're given a chart or two charts of function. Here we're given graphs. So as everything else, we start with the inside one first. So we go and find from our graph f of g of negative 2. So here we have f of g at negative 2. So we first of all find g of negative 2. Now, here we have the graph of g of x. So when x is negative 2, g of x would be 8. So 8. So we have to use our graph. We have negative 2 here, and on my x-axis here. So this is my x-axis. And x is negative 2, y, or g of x, would be, y would be equal to 8. Now, this is our original f of g at negative 2. Now, g of negative 2 is 8. So we can write that. Replace g of negative 2. Then we go to our f of x graph. This graph here. We find x equals 8. Then y is 3. 3 here. So we can conclude f of g at negative 2 equals 3. Let's look at another question. So we have g of f of 3. So first, we always start in inside f of 3. So of 3. So here's our f of x graph. So f of 3 is going to give me 2. So I'll rewrite my graph g of f at 3. So now f of 3 is equal to 2, so I've got g of 2. Next, I go to my g of x graph, so where x is 2, here on this graph here, g of x, when x is 2, y is 0. So I can conclude g of f at 3 equals 0. So just to review, we begin with the inside. Think of it as an example of order of operation. We start with the inside, so we find f of 3. So we go to our f(x) graph and find where x is 3. Now it's my 3 here. y is 2. Then I replace f of 3 with 2. So f of 3 with 2 here. So we go to g of 2. And we go on our g of x graph, find when it's equal to 2. So g of x equals 2, and y equals 0 here. If you want to pause the video and complete question 2 on page 295 of your textbook, and you check your understanding. That will be a good example of this question for you to practice. So example 2, practice question would be check your understanding on page 295. Let's look at 2 other examples for this section. So example 2, we just completed. Now we go into example 3. In example 3, we're given 2 functions. Notice the progression. The first one, we used tables. The second one, graphs. Now the third one, we were given equations. So now we have g of 2, f of g at 2. So we have f of x here, and then we have g of x. So we'll use a g of x graph, and then this will be, you substitute a value for 2 into x, and then we replace g of 2 with that solution, and then we take that and substitute it into the f of x, where x is here. So let's see how that looks. So first thing we do, we first find g of 2. So this f of g at 2, so g of 2, substitute 2 into, x equal 2. X equals 2 into 1 over x squared plus 1. So g of 2 is going to be equal to 1 over 2 squared plus 1. So g of 2 is going to be equal to 1 over 5. Now we have original question, f of g at 2. Now our g of 2 is what? 1 over 5. So we place that. So now we have f of 1/5. Now we equals x minus 1, absolute value. So we'll substitute 1/5 into x, so we have f of 1/5 is equal to 1/5 minus 1. Now be careful, this absolute value. So f of 1/5 is equal to, this is 4/5. Because although it's negative 4/5, its absolute value becomes, if you want a note for that, it's going to give me negative 4/5. But because its absolute value has to be positive. So we can conclude that f of g at 2 is equal to 4/5. And we can write that in decimal, which is 0. Okay, let's recap. So we're given our two functions, and we asked to find f of g at 2. Step 1, we start with the inside of it. We substitute 2 into our g of x function. The result is 1/5. Then we take the 1/5 and substitute into the f of x function, where x is, and we arrive at an answer of 4/5 or 0.8. So f of g at 2 is equal to 0.8. Let's look at the second part here. I'll just show a straight line. So here first, find f of 2. So substitute 2, x equals 2. Into, we're going to use the absolute value here, x minus 1. So we can write that as f of 2 is equal to minus 1. So f of 2 is equal to 1. Notice we had originally f of x is equal to absolute value of x minus 1. Now I'll rewrite with the question f of g of f at 2. Now this f of 2 is equal to 1. So now we go to our g of x. So we have 1 over 2 squared plus 1. Oops, that's 1. Why did I write? Okay, it's actually 1. So g of 1 is equal to 1/2. So we can conclude g of f at 2 equals 1/2. Okay, you would like to try question 3 on page 296 in the section check your understanding of your textbook. That's a good example of a practice question for this example question. The final example, example 4, asks you to determine the explicit equation. So we're going to find the explicit equation for each one. Now we're given the equation and find the domain and range. So the first one, A, so we have f of g at x. So we do first one, find g of x. Now g of x is x squared. Sorry, g of x is 3x minus 5. So essentially what you're doing, whatever f of x is, you replace the x with what g of x is. So g of x is 3x minus 5, and f of x is x squared plus 3x. So we write now f of x is equal to x squared plus 3x. So wherever x is, I'll replace it with g of x. So f of g of x is equal to g of x squared plus 3. So wherever x is, I replace it with g of x. Now, g of x is equal to 3x minus 5, because that's what g of x is. Square plus 3 into 3x minus 5. Do your wonderful magic. This becomes 9x squared, 3x squared minus 30x plus 25 plus 3 times 9x minus 15, so f of g of x. So f of g of x, final answer is 9x squared, because negative 30 plus 25 gives me, negative 30 plus 9 gives me negative 21, and then plus 10. Now this is a quadratic, so we can conclude a domain x set of real numbers, and the range would be where y is greater than or equal to negative 2.2. Look at b. So we have g of f at x. So here we have g of x. So wherever x is, I replace it with x squared plus 3x. So I have g of x, which is 3x minus 5, and I have f of x. So go back to my now, if I were to make it g f at x, so I have 3 into f of x minus 5. Now f of x is x squared plus 3x, so I have g of f at x is equal to 3 into x squared plus 3x minus 5. It gives me what? 3x squared plus 9x a quadratic. So our domain, I'll put the line across here. So our domain x x is a set of real numbers, and y is greater than or equal to, if you were to calculate the vertex, the minimum value is 11.75. And the last example, or question C, I'll just highlight the answers for now. So this is final answer. Domain. So C, we have f of f at x. So we have a double here. We have f of x, go back to our graph here. F of x is x squared, so we have f of x so wherever f of x is, we replace it with the same f of x. So this becomes f of x. So it becomes f of x squared plus 3 into f of x. You can skip this step, but I'm just showing you explicitly what is being replaced or substitute. Now I substituted now the value for f of x into wherever x is here. So we have f at x gives me x squared plus 3x, forget your square, plus 3 into x squared plus 3x. So f at x, do all your magic. If you're not sure, I'm just gonna make this a little more explicit. So in your calculation, you work all of this out. So we have x to the power 4. So we have x times x to the power 4. Then you have x to the power 2 times 3x gives me plus 3x cubed. Then the reverse, plus 3x cubed plus 9x squared. Bring down these, we have 3x squared plus 9x. Combining like terms, we have final answer as f of f at x is equal to x to the power 4 plus 6x cubed plus 12x squared plus 9x. So that's my final answer. Notice this is a quartic function. So this is a quartic. Compared to the previous two, they're quadratics. So in a quartic function, we can say all of the domain oops, this should be the range here. So domain x is a set of real numbers, and the range the y is greater than or equal to -0.225 25. So to recap, when we're writing the equation of a composite function, we always begin on the inside and then go on the outside. In this case, we are substituting one function into another wherever the x is. In this case, we have g of x is 3x minus 5. So substitute 3x minus 5 into wherever you see where there's x. So this becomes the value of the x in the first function. So if you would like to practice a similar question, check question 4 on page 297 of your textbook. At this point, you will want to try on the textbook assignment question on pages 298 to 301, questions 4 to 11. And also, the hand-in for marks would be from your chapter 4 combining functions example booklet is marked. You need to submit lesson answers for lesson 3. So lesson 3, there are 1, 2 examples, and 3, 4, altogether 4 examples. And this has to be submitted for marks. So let's conclude our lesson on the introduction of composite functions.